Welcome to Season 2 of the Carroll-Wells Gradient. In this episode, we arrive at a layer many frameworks rush toward too quickly. This is Episode 12, Layer 12, Working Quantum Gravity Ansatz, where we explore an intuitive way of thinking about gravity that connects curvature, information, and persistence, without equations, speculation, or claims of final answers. This is not a theory of everything. It is a working perspective, a disciplined way of asking the question differently. At earlier layers, we established something crucial. Persistence binds structure across all scales. The same informational constraints that govern atoms also shape stars and galaxies. Thermodynamics enforces cost. Collapse reorganizes structure. Modeling allows safe exploration. Gravity sits at the center of all of this. Yet, gravity is often treated as separate from information, or as something purely geometric. In this layer, we take a different approach. We ask not what gravity is, but what gravity does. At large scales, gravity organizes matter. It pulls structure together, shapes motion, and determines how systems evolve over time. But from the perspective of persistence, something deeper is happening. Holding structure together is expensive. Any configuration that resists dispersion, expansion, or thermal smoothing must pay a cost. That cost appears as energy, stress, curvature, or time dilation, depending on how we describe it. This leads to a simple intuitive idea. Gravity can be understood as the energetic cost of maintaining structure across space and time. This framing does not replace general relativity, it complements it. General relativity tells us how space-time curves in response to energy and momentum. The working Ansatz asks what that curvature represents in informational terms. Curvature is not just geometry, it is bookkeeping. It tracks how much cost is being paid to keep structure coherent. Where structure is dense and persistent, curvature is strong. Where structure thins and disperses, curvature relaxes. Nothing mystical is added. The same equations still apply. We are simply reading them through the lens of persistence. This perspective naturally brings information into the picture. Structure carries information, not symbolic information, but constraint information. What can move, what can interact, what can remain stable. When gravity binds matter together, it is also binding informational relationships. From this view, gravity does not merely attract mass, it stabilizes informational structure. Curvature, information, and persistence are not separate phenomena. They are different descriptions of the same underlying constraint, the cost of coherence. This is why gravity becomes dominant at large scales. As systems grow, maintaining coherence becomes increasingly expensive. Information must be integrated across greater distances and longer times. Gravity is the mechanism that enforces that integration. At very small scales, other forces dominate. At very large scales, gravity is the only force gentle enough and persistent enough to organize structure without tearing it apart. This is not coincidence. It is scaling under constraint. The working quantum gravity ansatz does not attempt to quantize gravity directly. Instead, it reframes the problem. If gravity reflects the cost of persistence, then any quantum description must account for how informational structure is maintained under thermodynamic constraint. In other words, quantum gravity is not just about combining equations, it is about reconciling discrete information with continuous cost. This is where the PIWCWG framework provides a bridge. Persistence governs what survives. Information governs what is constrained. Gravity governs the price of holding it together. Seen this way, gravity is not an anomaly in physics. It is the accounting layer that becomes visible when structure spans vast scales. It ensures continuity. It enforces cost. It prevents free structure from appearing without payment. There is no escape clause here. There is no hidden reservoir of order. Everything that holds together must pay. This layer does not claim completion. It offers coherence. It suggests that the path toward quantum gravity may not require exotic new entities, but a deeper understanding of how structure, information, and persistence interact under constraint. Gravity in this view is not mysterious. It is expensive. In the next and final layers, we turn outward again. We ask how these ideas lead to testable predictions, observational synthesis, and ultimately reflection, how a universe governed by persistence comes to understand itself. I'm Charles Carroll. Thank you for listening to episode 12. Join us next time as we move into episode 13, layer 13, experimental predictions, gentle fingerprints of a deeper order. There, we'll explore subtle, testable signals that could reveal whether persistence leaves measurable traces in cosmic structure.